Hi everyone, welcome to Chem Prep Hub. I hope all of your preparation is going very well. So, I'm back with another new video. So, this is another very good question. This is from JAM, IIT JAM 2023 question, most probably. This is, yes, 2023 question. So, it's a very good question, classic question of pericyclic chemistry. And most of the people actually get confused in these kind of questions. Okay, so this is substrate given, and in presence of copper sulfate, you have this kind of a substrate being given, being added. So let's start. Okay, so you have something like this. The butyl part is here, and you have your sulfur component here. Okay, so whenever you are being provided this kind of a substrate, disubstituted along with this kind of an arrangement. Okay, so always remember the fact that when you are provided copper sulfate, this actually promotes carbene formation. This actually promotes carbene formation. This is basically acting as a promoter, and this kind of substrates, they actually rearrange. Okay, this kind of substrates, they have the tendency of actually rearranging, and this is N2 positive. So ultimately, this bond cleaves symmetrically, and you get basically this kind of a substrate, this kind of a substrate. You see this kind of carbon, it has only two two bonds, and basically one incomplete or unfilled orbital is present in this kind of carbenic carbons. Unfilled orbitals are present, due to which carbenes are electrophilic in nature. Carbenes are actually electrophilic in nature. So the carbene always looks insert in those places where it can get the electron density. Okay. And normally many people have even done this question like that. Like for example, this is a carbene. They have tried inserting this into the pi electron density, and they have formed this kind of a product, a cyclopropanation type of product. Okay, for people who have done this. So this normally happens, but in this case, this won't be your answer. Okay, I'll explain to you why. Because the electron density in this case can come from two sides. One is this pi bond, the pi electrons. Another is this sulfur. This sulfur contains actually lone pair. Okay, and the donation of this lone pair towards the carbenic carbon is much more considered much more stronger donation of electron density compared to the loosely held pi electron density donation. So hence, in this case, your answer will be incorrect if you have simply inserted the carbene into the pi bond. Okay, so if you are having this kind of a substrate, okay, you are having this lone pair of sulfur, and now you are having the carbene. So now this sulfur is going to attack the vacant orbital of this carbenic carbon, okay, and what you are going to get is SPH. Since it has accepted the electron density, it is positive charge. Since it has donated the electron density, it will be having the positive charge. Negative charge on the carbonic carbon because it has accepted the electron density now. So now if you look at this kind of arrangement very properly, what you can figure out is that this is a very classic case of, if you look at it properly, it's 2-3 sigmatropic rearrangement. I'll explain to it how. So if you number it, this is 1, this is number 2 carbon. Similarly, if this is 1, this can be 2 along the double bond, and this can be 3. So you see, at this position you have the negative charge 2, this position you have the negative charge 3. So if you arrange this very properly, if you arrange this properly, you are going to get something like, let me bring it on the same side so that it becomes easy for you. So this is the negative charge, this is 1, 2, this is 1, 2, 3. So what you get, this is 2, 3 sigmatropic rearrangement. Okay, so basically this second position attacks the third position carbon, this bond moves here, and this satisfies the positive charge. So ultimately what you are getting, ultimately you get this methyl here, this NBU position here, and you have a bond here, and this thing is attached to the carbon having the two ester groups, CO2Me, and here you are having the SPH linkage because the bond has been shifted from here. So this should be your final product. So let us take a look at the options. So if you look at the options properly, this is already wrong, as I told you. In this case, direct insertion does not occur. So this and this, yeah. So this is what we are getting. So if you compare it with what we are getting, we have the methyl and the butane or the butyl group. We have the butyl group here, and there is a CH2 spacing and CO2Me, CO2Me, and SPH. Yeah. So what we are getting is this thing as the correct answer. So B is your correct answer here. Okay. So that's all for the video. Please subscribe to the channel to receive more updates and more questions. Thank you so much.